Good morning, chemistry class. This is Mr. Bennett back in the backyard lab classroom here. What I'd like to do today is talk about how to actually use a solubility curve. For this, you're going to need to go. It would be best if you could print out your solubility curve so you could have it, and you can actually write on it, or at least indicate on it with a pencil or a pen so you can really follow what we're doing here. You should get that before you go on with this video. The next thing I want you to do is copy down these questions, and then, so you probably would pause this now and then go get that stuff taken care of. Then we'll go through each one of these questions. And to do that, we're going to actually look at the graph carefully. In the first question, it says how many grams of NH4Cl, and that's ammonium chloride, are needed to saturate 100 milliliters of water at 70 degrees. So NH4Cl, that's this one, and 70 degrees. So you're gonna have to find NH4Cl, and that is here. So we're looking at this curve here. Okay, and at 70 degrees, so you're gonna find 70 degrees, that's right here. And then you just follow that up until you get to the ammonium chloride curve, which is about here. Okay? And so the question is, how many grams is that? Grams are on this axis over here, so you just follow along over this way. You could just draw a line if you wanted to. And that gets you to about 61, I would say, 61 grams. Would be the answer to that one. So for number one, we'll say 61 grams of ammonium chloride could be dissolved, are needed to saturate that much water at 70 degrees. Okay. The next question says, what if it was 50 degrees? We're going to use the same salt, ammonium chloride, but what about at 50 degrees instead of 70 degrees? So at 50 degrees, let's come over here, and we're going to still go up to the same curve, this curve here, the NH4Cl curve. So 50, go up to the NH4Cl curve and see where that hits right here, and then come on over to the side. And so it's a little above 50. So I would say 51 grams. So the answer to number two is 51 grams. Okay, one more. We're going to take a look at ammonia, NH3. Remember, NH3 is ammonia, and it's one of the gases that actually has a sloping to the right curve. So this is a gas, and so this is at 10 degrees Celsius, and we're going to look at the ammonia solubility curve. And at 10 degrees, so that's here, 10 degrees, you get to ammonia, it's about right here, right? And that would be about 70 grams. So 70 grams of ammonia would dissolve in 100 grams of water at 10 degrees. And you might notice also that as you heat up the water, less ammonia is dissolved, and that's because it's a gas. We've talked about that before. Okay? On the back side, I would recommend you would copy these down and then pause it, and then copy these down. But I'm just going to go right through them, and we're going to be looking at the solubility curves here. In this case, what I want you to do in the first case is you have 20 grams of salt, sodium chloride salt, dissolved in 100 milliliters of water at 50 degrees. The question is, if you have that situation, is the solution saturated, unsaturated, or supersaturated? How do you know? Well, if it's saturated, it's going to be right on the line. If it's unsaturated, it would be below the line. Below the line. And if it's supersaturated, it'll be above the line. And if you don't know what I'm talking about, you'll see in just a minute here. So we're going to take 20 grams of sodium chloride at 50 degrees. So we go to 50 degrees. First, let's find the sodium chloride line. This is the sodium chloride line right here. And so at 50 degrees, bam, So if you had 20 grams at 50 degrees, which would be here, you're going to be below the sodium chloride solubility curve. So that would be unsaturated. So the answer to 4 is unsaturated. Unsaturated. Okay, now the next case, we're going to take 23 grams of KClO3, that's potassium chlorate, at 50 degrees. And we're going to ask the same question. Is it saturated, unsaturated, or supersaturated? So 23 grams of potassium chlorate at 50 degrees. We're doing 50 degrees again, aren't we? Okay, so 50 degrees. And let's find our potassium chlorate curve, which is this one here. So we have potassium chlorate, 50 degrees, 23. It looks like the 23 is right on the potassium chlorate curve, right? 50, bam, 23. So since it's right on the line, this is an example of it's saturated. So the answer to number 5 is saturated. It's right on the line. Saturated. Okay. The last question involves NaNO3, which is sodium nitrate. This time we're going to dissolve 120 grams at 30 degrees and ask the same question. Saturated, supersaturated, or unsaturated? So let's go find the sodium nitrate curve, which is here. It's way up here. And at 30 degrees, and it's 120 grams. So 120 grams is here. 30 degrees is here. So you can see that's up here. It's above the line. So if you had a solution with 120 grams of sodium nitrate, it would be supersaturated at that point. Supersaturated. That's it for today's lesson, and we'll see you next time.